Okay. All right. Good afternoon. Sorry about that. My Zoom wouldn't launch. Acting weird. All right. We started a worksheet the other day and we need to finish it. Um, so we are working on, so let me get there first. Then I have some other dates I need to tell you about. All right. So we are in the DNA module. We are working on mutations. And we started working on this worksheet the other day. So we need to get it finished today. Or at least try to get it finished. We won't get it finished today because I got some other announcements I need to make. Um, It's going to take a few minutes. All right, so but just make sure you have this worksheet down. We've completed the whole first page, questions 1, 2, and 3, and I think we got as far as doing point mutations. But I'm going to start from here, and we're going to get through this page together. All right, but before I do that, um, because you are a milestone class, you have to do a benchmark. So the school has set up some benchmark exams, and like I'm here on your page, just so write these down because these are some dates that you need to be aware of. And we're going to talk about what you need to do to prepare yourself for it. All right, so this is the calendar that they have for your exams. All right, the first week of December, which is the week we come back from vacation, we're off next week. Then as soon as we come back is December 1st. And unfortunately, that's the day that you are assigned to do the benchmark. So then we want to do it on the first because if you don't finish, there's time for you to finish it on the Wednesday. Okay, so we need a full class period to get that done. So make a notation to yourself that on December 1st, the day that we come back, so don't take an extra vacation, come on back. We're doing the benchmark for biology. And that's going to be listed. And some of y'all aren't even listening. And then when you come back on Monday, you're going to be like, wow, I didn't know. Pay attention. Pay attention. We're taking a benchmark exam. It's important. And it covers benchmark exams cover everything that's supposed to be in the course. So some of it we'll have covered and some of it we won't have covered. And the school uses this information in order to see your progress and where they should place you if you should need some extra help because they assign extra classes in preparation for the milestone. So they use this for judging where to place you. Okay. So write that down. December the 1st, biology benchmark test. And it's in progress learning. She said it's 40 questions. But again, you'll be given extra time if you need to finish it on Wednesday. We will continue. So instead of being as that's a big test, instead of doing a end of term test, we're just going to finish the unit on for you, it's December the 11th, Thursday, December 11th. We will have a unit test on December 11th. So this DNA unit, we'll test the whole unit on December 11th. So write that down on your calendar. And it's like I said, some of y'all ain't even paying attention. When the test pops up, like, yeah, I didn't know. You didn't tell me. I'm telling you. And you're not writing it down. All right. So December 1st, benchmark, December 11th, end of unit test. And then the week after that, we just have some other activities that we need to do and gives you time if you owe anything to get that in because grades have to be finalized on Friday, December the 19th. And if what's not in by the 19th, that's a done deal. So if you're one of those who's trying to catch up and make up and do extra things, it has to be done by the 19th. Otherwise, that's the end of the semester, and there is no looking back, no coming asking for mercy and all that kind of stuff. It must be done before the 19th, because if I have to grade it and get it in the grade book, it's got to be finished before the 19th. Okay? All right, and then we're off for the holidays the following week. All right, that being said, what I want you to also do now, that'll help you in preparation. Come on. My computer's slow today. I want you to download the review page for this unit. So every unit ends with a review page, and we've done most of them. So we are up. So we have done the first unit on science of life. We've done macromolecules. We've done cell and cell transport, cell energies, and now we're on DNA. So we've completed all of those. So you should be able to go through all of those reviews. Some of those you had to turn in. And now I want you to download this because I see you again tomorrow. Tomorrow we'll probably start going over this because a lot of this will be, well, I would say a lot of it, but there will be definitely be questions on the benchmark about this. So I want you to download this page and tomorrow we'll start working on it, but you can start working on it because we won't get it all done tomorrow. And again, as soon as the day you come back to school, that's the day that we are, you're doing your benchmark. So please make sure that you are preparing for it over the break. Okay, don't come in there and feel like you can wing it. It's a lot of information. They want you to take it seriously, to answer it to the best of your ability, because again, you are going to be placed in classes based on the results of the test. Okay. All right. So download this. We'll work on this tomorrow. And now we're going to go and any questions about that so far? So now we're going to go back and finish today's worksheet. Come on, go back. All right, so we're almost finished with this unit. We have to talk about technology. Finished talking about what in the world? All right, my screen is doing weird things. There we go. Trying to just go back rather than go back to the module. All right, here we are. All right, so as you see, we just have one more unit to do, one more lesson to do. All right, so again, we finished the first one. So we completed a row. We have transcribed the DNA into an RNA strand, and then we went to our chart. And again, if you can do a split screen where you have the chart on one side and the worksheet on the other, that would be helpful so that you're not looking back and forth trying to look that up. All right, so let me get mine in front of me. All right, so with me, I printed it so I just tore the page off so that I have it separate and can glance. All right, so what we're up to now are these different types of mutations. The first one is a point mutation, and what we looked at here with the insulin was for diabetes. Insulin, if you don't make insulin correctly, then you don't break down the sugar properly, and you get diabetes. So that's a disease that comes from this type of mutation. And a point mutation is just one base is affected. Okay, only one base is affected. But when that base is changed, it changes the sequence of the amino acids and it creates a protein that is either less functional or not functional at all. And if it's not functional, then the protein can't do its job. And in this case, it's not helping the person to break down the sugar the way they should. So they end up with diabetes, which means it leaves the sugar in the blood. And then you have, instead of uptaking it to your cells, it remains in the blood and it doesn't, and you never get energy. Because that's what the sugar is supposed to do. Remember, we did carbohydrates. It's supposed to give you energy. So they will have low energy. All right. So we did that and we looked at it. Says suppose a person had a, and we did this one, so I'm going to go do it real quick. Suppose a person had a mutation. So again, this up here that we did up here was the normal cells. So we use this as a comparison. This is what they should look like if you're a normal human for making insulin. So down here, they're saying, suppose you take this first one, this CCA, and you change it to TAT. So we wrote that down. I believe we got through this. And we said, if we look on our chart and we do T, we're going to translate this first into an RNA. So the RNA would be AU, because there's no T's in RNA, AUA. And we said it was going to be ILE. The amino acid that it's going to pick up is isoleucine, ILE. Okay, so that's what we put there. And so then it says, will this person have diabetes? And we said, yes, because there was a change. Yes, because, and you can just go right back up here and say, because the amino acid sequence was changed, and therefore it did not create the protein for insulin. Okay? That's what you should have for number 4. Now I'm going through all of this, and you should be writing all these answers down. So when it's time for you to turn this worksheet in, there'll be no blank spaces. All right, next one. Silent mutation occurs when the nucleotide changes, but the resulting amino acid is the same. So we're looking at that same first one, and it says, suppose the first triplet code, instead of it being CCA, is now CCG. So we're going to translate our CCG into GGC, and that's going to code for glycine. Well, if we look back at our chart when we did it the first time, I got to turn my page. We did it the first time, even though it's a different code, it also coded for glycine. And that's because there were several ways to get glycine. There's 4 different ways you can code for glycine. So it still produced the same amino acid. So your answer here is this person will not have diabetes. This is silent because you are producing the same amino acid, so there's no change in the protein structure. That's the answer you put there. So hopefully you did that. And if you've done that, let's move on to sickle cell anemia, which is, I think, where we left off yesterday anyway. All right, with the sickle cell disease, these, let me bring mine up so I can make sure you're seeing my pointer. Oh my goodness, go away. All right. All right, this is a picture of the blood cells over here. Normal blood cells are nice and round, look like a donut. That's a red blood cell. When you have sickle cell, they look long, elongated, like a sickle. And the shape of the red blood cell determines how much oxygen. The job of a red blood cell is to carry oxygen. And it does that because of a protein called hemoglobin. The oxygen binds to the hemoglobin. All right, so you can carry more oxygen when the cell is shaped correctly. So the first row wants you to do the normal shape of the hemoglobin. So fill that in. And again, I wish mine was in such a way that I could write on it. And again, hopefully you are filling it in and you're not just sitting there waiting for somebody to give you the answers. All right, so the first one is the normal one, and then you have to translate. So the row of RNA is a triplet code. The row on the bottom, even though you're using 3 letters at a time, those are abbreviations for the amino acids. So don't get that confused. One is a triplet code for nucleotides. The other is just a 3-letter abbreviation for the amino acid. Once you've completed that, fill in the second row. The second row is what a segment on a protein would look like if the person has sickle cell. So fill in all the boxes. And as you go through, you'll see that they're almost exactly the same. So this should be easy. You just transfer the information from the top to the bottom until you get to CTT. And the one on the bottom is CAT. So I want you to tell me, what is the amino acid for CTT and what is the amino acid for CAT? So work on that for a minute. That's the information I need to know. And I'm going to do attendance and I'll be right back. Now again, I expect you to be working on that while I'm doing attendance. When I look at GoGuardian, I need to see everybody working. Like I said, some of y'all do all kinds of other things and you're falling behind. This is the only class I have to worry about calling home and folks being off task. All right, we have a lot of people. There's a field trip today, so we got a lot of people who are missing, but they still have to. All right, Ethan says that all right, Ethan, which one is that? Is that your CTT? Okay, none of these are going to be CCT. Okay. All right, so the one that's wrong is going to be, if you're doing this right, it's the one that's going to be, that is different. And you can see the difference. All of the letters on both of the charts are the same, except for the fourth one. The fourth one on the normal one is CTT, and the fourth one on the mutated one is CAT. So what is the amino acid? When you translated CTT, what amino acid are you looking for? And when you translate CAT, what amino acid are you looking for? All right, Val is going to be the one for CAT. All right, and folks, when you don't answer in the chat, could you answer to
Which
everybody and not?
which one are you talking
Like,
about? I don't see a CAT.
we're looking at sickle cell. I'm on question number 6. And they give
Question
you
number
2
6, yes.
charts. There's 2 charts.
On
One is
which?
for normal. Okay, give me 1 second to finish doing
Oh
attendance,
yeah,
and I'll
under
share
it.
again.
I thought they were talking about the first one. I was like, see.
The first one is CC. The first row. 1, 2, 3. Fourth one. The fourth code is CTT. And when you're looking at,
Wouldn't that transform into GAA?
yes, it does. And my question was, what is the amino acid that you're going to get?
Glycine, I think that's what it's called. GLY.
Not, no, that should be, hold on. I think some of y'all are looking at the wrong one. GAA. GAA is GLU. It's glucine. You're all in the wrong column. All right, give me 1 second. Y'all in the wrong column. It's GLU, not GLY. Because it should be the third column. A is the third column. So G is the last row. A is the third column. And then you're going to A again. So you're in that box on the fourth row, third column. You're looking for GAA, and that's glycine. Hold on. I don't see anybody that should be missing. So folks just ain't come to class. All right. Got a lot of people missing here. Okay. All right, y'all see what I was talking about? Tracy is not here. Okay. Okay, sorry about that. This thing was not giving me the right information. Okay. All right, I'm gonna bring mine down to the chart because two of y'all were telling me GLY and you misread that. All right, so you said that if I translate CTT, it's going to be GAA, which is correct. So G would be our last row. A would be the third column. If I come down the third column to the last row, I have GAA, and that's GLU. So that's glucine. Okay. The second one, if I'm going to do CAT, CAT is going to translate to what? Yeah, that's the answer. But what did it translate to? It's going to be Val for sure. It's going to translate to GUA. So G, bottom, first column, last row, first column, and we come down to GUA, and that's Val, and all four of them happen to be Val anyway. All right, but our point is the first one was GLU, and now this one is Val. So there's a different amino acid altogether. Okay, it's not even that there's four ways to write it. It's a totally different amino acid. Therefore, when we come back up here, so you should have put Val. So and again, all the rest of them should be the same, except for this one right here. And that one is going to be Val. So what type of mutation is this? Is it point or silent? Is it going to be point or silent?
It's gonna be silent.
No. If there is a if there's if there's a different mutation altogether. Silent is when there's no change at all. For example, when we did this one before, we got the same, even though, so let's go back up there. If we, for the insulin one, we did GGC, which was different to the one that we got on our chart, but we still got glycine. So it was a change in the amino acid sequence. I mean, it was a change in the nucleotide sequence, but not a change in the amino acid. It still created the same chain of amino acids. So it is a point mutation. Thank you, Ethan. It's a point mutation because it was changed. There was a change, and that change created a protein that was less functional. In this case, it's less functional because it functions a little bit, but not good enough for it to work the way it's supposed to work. Okay, this was a point mutation. All right, so down here on the line for number 7, point mutation. Okay, again, silent mutation was there's a definite change in the nucleotide, but it still created, that change still created the same amino acid, because some of these amino acids have 2 or 4 ways that you can write that, get that same amino acid. Okay, so some of the changes are good, some of the changes are detrimental. All right, we're going to shift to frame shift mutations. All right, so look at the picture. In this case, the amino acid chain sequence, because we read it in sets of 3, if you insert, so right now we're inserting an extra nucleotide. So the top one is the normal one. And down here on the mutant one, they've highlighted it by shading it in by saying they stuck an extra one in there. And that pushed the chain down. So now you've got this T over here. And while it looks like it's sitting by itself, it's actually going to be part of the next set of 3. But the point is, now instead of it reading AGT, it's going to read AAG. Excuse me. So take a few minutes to translate and then find the amino acid, and then translate this one and find the amino acids for that. And then answer the question, why are frame shift mutations likely to cause more problems than a point mutation? And think about it. Like I said, this little T over here is not sitting over here by himself. It's really connected to the next set of triplets. All right, everybody should be working on this. We got, how much time? We got 10 minutes, 5 minutes. This class goes quick. Got somebody from the next class already trying to get in. That's early. We got 5 minutes, so 5 minutes, 5 minutes. Let's try to get this one done. So again, you need to translate the TGG. All right, if you did that correctly, the first one should be, and that will be the first one on both of them. Because the problem is not with the first set of codes. The problem comes with the second set. So the first one is ACC, which brings the amino acid of thurine, THR. The second one, the normal one, should be UCA. which will bring Serling. And then on the bottom, it'll be AAG, which is lysine. But that's just a second. Then watch what happens to the rest of them after you go like that through that, and then tell me the answer to that question. Mm. All right, everybody try to get number 8 done before you go. And somebody put an answer to the Y in the box for me before you go. Before you go, we got 3 minutes.
It's more problematic than the point mutation because it adds an extra DNA that is not needed.
This is not DNA. This is a nucleotide. I know we need to talk about that next class too. Each one of those letters is a nucleotide. It's not the whole DNA. But what did it do to the sequence? If you finished all of the other two, is it the same for the rest of them after it?
No.
No. So it changed the whole chain, not just one. So point changes one amino acid. This insertion changed all of them. Okay. Everybody see that? The other, from the point of the insertion, all the other 3 are going to be different as well. Okay, so this is worse. You're going to create a whole new, not just a defected substance, you're creating a whole different protein altogether. Okay, all right, it is time to go. I got folks lined up for the next class already. So again, make sure that you finished this number 8. We'll start from number 9 tomorrow. I'm gonna make a point here. 5th period, number 9. But you can go ahead this evening when you have nothing else to do 9 and 10. Because again, what I want to do is to start that review page with you tomorrow as well. So I want to finish this and get as much done on that review page as possible. Okay. All right. So hopefully you were filling this in because practice makes perfect. All right, bye. Have a good rest of your afternoon. Thank you, Ethan, for participating.